What's up guys, back again with another video in the C++ series. This time I'm going to show you how to use access specifiers. So access specifiers are going to allow us to achieve data hiding, which is something I mentioned last episode when I gave you a brief overview of how classes work, the object-oriented principles and stuff like that. And data hiding was one of the biggest ones. That allows you to hide data and functions within a class from the outside world. And that's what we're going to be able to do this episode when we use access specifiers. And we actually used access specifiers last episode, sort of. I told you to use the public keyword, and I didn't tell you what it does. I mean, I told you what it does, kind of, but I didn't really go over it in detail. And that's what we're going to be learning this episode. And we're going to be using private and public to achieve data hiding. So let's just jump right into it, okay? So what we need to do first is make a class for us to work with here. And I think we're just going to stick with the car example. So we're going to do class car. And a car, let's think about what a car is made of. And we're going to make this public just to start with, like I told you from last episode. Just take my word on that. And so what does a car have? What properties does a car have? A car has a make. So some basic stuff is a make, a model, and then let's do one more, a speed. So a double speed. And so those are attributes for our car. And our car can also have some different functions, right? So what would be some functions that a car would have probably? Maybe the car would speed up and slow down. So void speed up. And so that's going to be, it's going to take a increment. So the amounts that you want to speed up the vehicle by. And then we're going to have the same thing for slow down. So double decrement. All right. And so these are just function prototypes. And like we saw last episode, we can define these inside the class if you want to, or we can do it outside the class. And we're going to do it outside the class because that's the convention, unless the function is really, really simple. But we're going to do it outside. But anyway, now that we have a simple class definition here, we can then be able to create instances of that class, which are objects, right? So we can do car1, and we could say car1 dot make is equal to blah blah blah, right? We can set the various attributes of the car. And so as you can see, we can access these three variables here, make, model, speed, by doing the dot operator, make, model, speed. And you can also access the functions here. And the reason you can access all of these with no problems is because they're public. Public means that they can be accessed outside of the class definition or the class specification, okay? If it's private, if there is a private keyword here instead, right there, that means that they cannot be accessed outside of the class definition. They can only be used inside the class definition or within the function implementations, okay? So as you can see here, it says it's red now. So if you do the dot operator, it doesn't show any of these variables here. So if we do make, we can't do that because make is not accessible outside of the class definition, okay? So what we need to do is basically use a balance of private and public. So you can specify private at the top here, and then anything under that is going to be private. All the functions and variables under that will be private. If you want some public variables, then you can put public, and then anything under public will be public. So that means it can be accessed outside the class definition, okay? And so let's say that we want these two functions here to be public, but not these three variables here, right? We can just cut these and put them here. And so that means that these variables cannot be accessed. So dot, you can see only the functions can be accessed, and we can call slow down and speed up pretty simply, right? So that in essence is how you can use basic access specifiers to use some very basic data hiding. See, this is the data that we're hiding, and then we have this these two functions here which are going to manipulate the speed variable here, okay? And it's common practice whenever you make a car, or not a car, but any class, the variables of the class are usually all going to be private, unless for some reason you want to make them directly accessible for some special reason. But the common practice is, the convention is to make all of the variables of a class private. So that is going to prevent the user from using these variables and directly accessing them and manipulating them however they want to, right? So if you want the user to be able to access the private variables of the class, you're instead going to make a bunch of public functions called accessors and mutators, okay? So let's go ahead and let me show you what those are, okay? And these are also called getters and setters, and I'll explain that more in a second, okay? So let's say we want the player, or not the player, the user of our class here, to be able to access the make and the model and the speed, okay? Then that means we're going to make accessors for that. So these are just simple functions that return these three values here, okay? So let's make an accessor for get. So we're going to do a string, so it's going to return a string, and it's going to be called get make. And that's all it does. It returns a string of the make of the car. And then we'll have another getter or accessor, whatever you want to call it, for the model. So get model. And the reason it's called accessors or getters is because it's simply getting the value or accessing the value. It's not changing anything. But there's also another type called mutators or setters. And that is useful if you want to provide a way for the user of the class to be able to set these variables here without having to directly access them because they're hidden, right? If you make a function for them to be able to manipulate these variables here, that means that there is a set way for them to manipulate the data. They can't change it however they want to. They have to do it through the function, which is a interface. And we'll see that concept more in a second. But let's go ahead and make another getter for the speed variable. So double get speed. And you're going to see this with almost all classes. This is a very common class design concept, okay? And yeah, so now we have getters for each of these values here, so we can also make setters for the ones that we want to be able to have the user change, okay? So let's say we only want the user to be able to change the make and the model directly with a setter or a mutator, okay? But we don't want them to change the speed variable. That means that we don't have to create a setter for the speed variable. We can only create setters for the ones that we want to be able to set, which is pretty simple, right? So we can hide the data we want to hide and then allow limited access to the variables that we want to give access to, basically, so the hidden data. So yeah, let's create mutators for those, or setters. So we'll do void set make, and it's going to take a parameter, not like this, so new make. And it's just a prototype, right? Just like these up here and here too. So we're going to define it outside the class in a second. And then we're going to do void set model, and then we'll do string new model. And like I said before, we don't want them to be able to set the speed, and that's because we have these two special functions here for explicitly speeding up and slowing down the vehicle. And that is important because if there's a set way for the user to be able to speed up and slow down the vehicle, that means that they can't just directly do, like, you know, set speed and then set it to whatever they want to. They have to follow, or they have to use these specific functions for doing so. And that's just how we're designing our class. You can design the class however you want to. It's up to you, okay? Anyway, so now that we've got everything here, just to recap, these are our hidden data. We're using data hiding to hide those variables of the class so that the user can't directly access them and manipulate them however they want to. And then we have some basic functions here for changing the speed of the vehicle. And then we have some getters and setters here. So these are just three functions that are going to get each of these hidden data variables here. And then here we have two setters for setting the make and the model of the vehicle, okay? And let's try testing these out. Well, actually, we need to define them first, don't we? So let's go ahead and start with these simple ones first, and then we'll define the speed up and slow down functions last, okay? So let's go down here, and we'll do string car scope resolution operator, and then get make. And then inside of get make, we want to provide the implementation for the function. So it's just going to return make. And as you can see, even though we are outside of the class definition, we can still access the make variable because we're in the car scope, and technically we're still inside the class. Basically, you can think of it that way. So you can access the make variable even though it's private inside of the class, or at least inside of the car scope for the get make, for the function definitions, okay, or implementations. Hopefully that makes sense. So just remember, you can't access it through the object. You can only access it through the implementations of the class, the specifications and the implementations. Yeah, so that's how you do that for the get make function. There's a shortcut you can use if you want to, because this is kind of tedious, especially as your classes get bigger. Hover over this and do show potential fixes and say create definition, and it's going to automatically create it for you. And you can just click the X here, and it's going to generate the code basically, as you can see right here. And yeah, that's a quick way of doing that if you want to, or you can just, you know, not be lazy and type it out. So car scope resolution operator get speed, and so it's just going to simply return the speed here. And what's the problem? Oh yeah, it's not a string, right? It's a double. Don't forget that. You have to match it completely, pretty much. And so now that we have the getters, let's go ahead and set up the implementations for the setters here. So void car set make, press tab to autocomplete, and now we'll do make is equal to new make, and that's all that does, right? Pretty simple process. And void car set model string new model is equal to new model, and there we go. So now that we've created the setters for our what's the problem here? Oh, okay, no problem. And yeah, so we've created the setters for our program and our getters and our other stuff, but now we need to create these two functions here, and we'll define them at the top just so they're easily accessible. So we're going to do void car scope resolution speed up, and so what we want to do is well, we're just going to speed up the vehicle pretty much. So we'll do speed is equal to speed is equal to speed plus increment. So we're simply increasing the speed by the amount provided, okay? And there we go. So pretty simple process, but the slow down function is going to be more complicated or more refined. So car slow down double decrement. And so what this one is going to do is if the new speed, so first we're going to subtract it. So if speed minus decrement is less than 0, so if the new speed after, you know, subtracting it from the one provided is less than 0, then we're simply going to set the speed to 0. So the minimum speed is capable, the minimum speed is 0. So if it ever goes negative, we're just going to set it to 0 automatically. And then else, if it's not lower than 0, then we're just going to set it to whatever the new speed is. So speed is equal to speed minus decrement. All right. So as you can see here, this is providing like it's more refined, right? There's actually something going on behind the scenes rather than just setting the new speed. We're actually checking to see if the new speed is going to be less than 0, negative, and if it is negative, then we're going to set it to 0, so it's not capable of going negative, right? Realistically, I guess it would make sense if a car could go negative. That means it would probably just go in reverse, pretty much, but that's okay. So hopefully that makes a little bit of sense. And so why this is so important here, since they have to use these, they can't set the speed incorrectly. They can't do something to the class that we don't want them to be able to do. So for example, if they did, if this speed variable was public, they could go down here and do car1.speed is equal to negative 150, right? We don't want them to do that because, as you can see here, in the slow down function, we tell it if it ever goes negative to just set it to 0 as the minimum, right? So if we force them to use this function here, we can make sure that they're always using the class correctly. So these functions here are an interface to the hidden data, and that makes sure, well, first of all, security, like I mentioned before, but also, like I said a million times now, it makes sure that you're able to, that the user is using the class correctly according to our design and stuff, okay? So hopefully that makes sense. And so we have successfully modeled our class now, so let's go ahead and try using it to just test it out now. So car1, and so as you can see, again, since these are private up here, we can't directly access them, so we have to use these getters and setters here. So let's set the make in the model. So set make, and we're just going to use it as a simple function like we normally would. So just provide a make here. We'll call this the booty mobile, and then car1.setModel Maximus. So the booty mobile Maximus is our car, our make and our model. And so we can't do car1.setSpeed, right? So we have to do this speed up and slow down function. So if we want to, for example, well, first let's print out these two variables here to make sure that it worked. So cout, this is my car. And so cout, and we can, again, just to recap, we cannot do, you know, car1. make to access it directly. We have to do get make using the getter, right? And it's called a getter because it's only getting the value. It's not changing the value in any way, okay? So let's just do car1. Let's add a space here. Got .get model. So that should say this is my car, Bootymobile Maximus. So let's run this now and see what we get. There we go. So we get this is my car, Bootymobile, and it does not say Maximus. Interesting. Oh, okay. See, look what I did here wrong. So up here, when I used the auto generate feature, it didn't put the what I wanted. It put just this string here. So yeah, we don't want that, right? So we want to use or return the actual model itself. We don't want to return a new string. Okay, so that's just a quick mistake. So let's rerun this now, and it should fix the issue. So boom, and it should say, yep, there we go, Bootymobile Maximus, exactly what we expected. So now let's try speeding up our vehicle. Let's say we want to go to the store and get some potatoes. Then we want to, increase the vehicle speed so that we can go there. And so we'll do car1.speedup, and we'll set this to 20. So 20 miles per hour if you're American. And so cout car speed. So car1.getSpeed inline, okay? And yeah, that should do the job for us. So let's run this now. So that should set the speed, so 20 miles per hour, or speed up, not set the speed, but it should speed up the vehicle by 20 miles per hour. But as you can see, there's a problem here. It says car speed -9 point whatever, and that's because we don't have the car does not have a default speed whenever we first create the object, so it's just going to have a garbage value in the place of the speed variable. So if we increase that garbage value by 20, then we're just going to get literally that garbage value plus 20 and print that out. So we want to make sure that our car has a default speed whenever we create the car. So what we can do is go up here and set it equal to 0. So what that means is that every time you create a new car, the speed is going to be automatically set to 0 by default, okay? Unless you change it in any way. And in this case, the only way for the user to change it is to use the speed up and slow down functions here. So now, since it's not going to be filled with a garbage value, it's going to have a 0 as the default value. Whenever we create a new car, it should be 0 because we're increasing it by 20 with the speed up function here, okay? So let's try that out. And there we go. So we get car speed is equal to 20. Exactly what we expected. And so now let's test out our slowdown feature. Like I said before, we have it so that if it ever goes negative, it's just going to set it to 0 automatically. So let's go ahead and do cout, or not cout, we want to do car1.slowdown, and we want to set it to, let's do 30. So that should, or 32. So that should be -12, basically. And so that should be 0 actually, because of course, like I said, if it ever goes negative, it's going to be set to 0 if we designed it correctly, okay? So we're going to do 20 minus 32, and let's see what we get. There we go. So car speed is 20, then we change it, and then we get 0. So exactly what we expected. So this is working correctly. And again, this is very important because since the user is forced to use the slowdown function instead of anything else, they cannot, mess it up. We have designed it so that if it ever goes negative, set it to 0, okay? And that can only be achieved with the function since we're forcing them to use that, basically, okay? Anyway, so that's a very important concept, and that's pretty much it for that. And yeah, one more thing I want to show you here is that for our getters here, our getter functions, we can add a const to the end of it. And you can think of this as a promise to the C++ compiler. You're telling the C++ compiler that in this function here, in the function implementation, you promise that you're not going to be changing this value in any way, the make value or any value of the class. You're only going to be getting it or accessing it basically, right? And in this case, we're just returning it. We're not going to be changing it in any way. And since we changed the prototype up here, we need to go down here and set it here too. So that's going to, again, just be a promise telling C++, the compiler, that you're not going to be changing anything. You're only going to be accessing or getting, okay? So we can add that for each of these. And it's kind of just like like I said, a promise, right? It's kind of like also a safety feature just to make sure that you're not messing up anything. So hold on, let me fix this. So it's also a safety feature in the sense that if you were to accidentally do make is equal to 23, the Visual Studio is going to say, hey, you can't do that because this is a const function, right? So it knows, it's able to basically remind you that you promised that you're not going to be changing any values inside of this function here. So it's going to remind you not to, mess it up. So, or just follow that promise, I guess. So that's how you can do that if you want to, if you're interested in, that's a good design pattern, I guess, or convention. And yeah, obviously we don't want to do that for these here, the setters, because we're actually setting and manipulating our class's variables with these two things here, okay? But yeah, that's pretty much all I want to show you for this episode. That's how you can use what's called access specifiers, which is private and public, to do some basic data hiding. There's actually a third access specifier called protected, but we're not going to explore that until later when we get into inheritance, which is a big, programming object-oriented principle. But yeah, those are the basic ones for so far. So make sure you follow that basic pattern whenever you create your classes, because data hiding is very essential. It's a good practice to follow, and it encourages you to design your classes very intelligently, because as you can see, we're forcing our user to go through certain functions instead of just using our class however they want to and messing things up potentially. So get used to that. And just a simple rule to follow is to make everything private, your data at least, make your data private, and then your functions. Well, actually, something I didn't tell you is that you can actually make your functions private too. I'm sure you already understood that, but I just want to show you here. We could do, for example, if we wanted to, we could do void do something. And this function here, let's just define it within the class real quick. So void do something, we're going to see out blah blah. So that means that the function cannot be called without outside of the class. Sorry, I can't speak. But so we could do car1, and we cannot do something outside of it, okay? But we can do it within the class, or within the class, the function definitions for the class. So inside of get make, we can call do something if we want to without any problems here. And wait, what's the problem? So for some reason, if I remove the const thing after the function prototype, it lets me call this function inside of here. But if I put it inside of a function implementation that does have the const, it does not let me call this function here, which is kind of confusing. Ignore that. But yeah, play around with that if you're interested. I'll look into that also. But y'all get the point. You can either hide data, which is what you're going to be hiding most of the time, but you can also hide functions, which is important if you want to have functions for stuff internally that you don't want to, provide to the user, right? Because functions are important for grouping together statements. So you could have statements within the class that are going to be used internally within the class to do certain things and do certain actions, but you don't want the user to be able to access them themselves. So it would make sense to make those functions private, okay? Stay tuned for next episode where we explore implementation and specification files. If you have any questions about what I showed you this episode, feel free to leave a question in the comment section below or join our Discord server. We have a big Discord server with over 1,300 members last time I checked, so if you need any help at all with your programs, you can hop into one of these help channels and get some help. You can also just hang out and get some new friends if you want to, so just make sure you click the invitation in the description below. Don't forget, in the description below, I'll also leave a link to the code for this episode, so you can come back to it at any time and use it as a reference. I'll leave good detailed comments around the code so you can have a good explanation in text form too, in case you don't want to watch my awesome videos again. One final thing I want to tell you about, if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month. If you join, you can get cool perks like a special Discord rank on my server, early access to these videos, and you get shouted out like you see on the screen right now. If that sounds good to you, feel free to join for, like I said, as low as 99 cents a month. Alright, that's it. So thanks for watching. If you like this video, leave a like. If you want to see more, subscribe. And